On page 5 and 6 of our Unit 2 notes, we're looking at finding the equation from a linear table. In the most basic sort of table, like we're looking at on page 5, the start value is given directly in the first row of the table. It's our y value when x equals 0. So in this case, for this table, the start value is 4. It's what we start with. And then our rate of change is how much y goes up or down by when x goes up by 1. So in this case, our rate of change is -2. I'm still accepting either way of writing the equation. Y equals 4 minus 2x, or if we're using y equals mx plus b. My b goes in here, my m is -2, so y is -2x plus 4. To me, y equals 4 minus 2x makes more sense. We're starting with 4, and then we're repeatedly subtracting 2. But sometimes you're asked to write the equation in slope-intercept form, and that would be y equals -2x plus 4. When the x value is not going up by 1, and instead, for example here, going up by 3, my rate of change is not just how much y is changing by. In this case, y is going up by 6 every time, but now x is going up by 3. In this case, I find my rate of change as delta y over delta x. That little triangle is a delta. It means how much y changes by divided by how much x changes by. We are not writing y divided by x. That would be like 13 divided by 3, and that is not the correct work. We are writing delta y over delta x, which is 6 over 3, or 2. What this means is if I were to fill in my table, every time x goes up by 1, y would be going up by 2. Every time x goes up by 1, y is going up by 2. You don't have to show that. I'm just showing you where this 2 would be reflected in the table. Here I am just given the start value, so my whole equation is just y equals 7 plus 2x, or y equals 2x plus 7. If the start value isn't given directly in the table, well, sometimes it's just not given in the first row, so you just need to be careful and make sure you're not looking for the first row, but rather for the y value when x is 0. So here I still have a very straightforward rate of change. My rate of change is 5. My start value is 15. My whole equation is 15, y equals 15 plus 5x, or 5x plus 15. Here, when the start value isn't directly shown in the table, you're going to need to find the rate of change and work backwards. This nicely has a very straightforward, simple rate of change. The rate of change is -3. So I need to go backwards. If we're repeatedly subtracting 3 to go backwards to x equals 1, I'm going to add 3. That's not my start value because that is my value when x equals 1. So I need to go back again. So from 12, I'm going to add 3, and then there is my start value. This is a good strategy when the table gives x equal to 1 or 2 or 3, and you don't have to go back very far. So y equals -3x plus 15, meaning we start at 15 and then we repeatedly subtract 3.